Well, welcome again. Thank you for coming, and thank you, Tyler and Kevin, for presenting tonight. It's just great to have you present. I mean, we were here in person last time, and you've been around, and a lot of people know you, so it's kind of fun to have you present. So I'm going to leave it up to you, as we talked about before. Well, I should have asked before. Questions before, after, during? What do you want? Matter?
I mean, if people have questions ahead of time, we can surely answer them. But yeah, feel free to stop us as we go along, or if you want to just wait till the end, that's fine too.
All right, take it off.
Awesome. Well, thanks everyone. Happy to be here. Yeah, I used to come to these things pretty regular, but when I lived in Utah, and so unfortunately they will have to present remotely, but it's all right. I still appreciate it. Okay, so let me see if I can share my window here, and we can get started. Awesome. Okay, so now if I can figure out how to do the I don't do a lot of these things. Usually Kevin does these things. Slideshow. There we go. And hopefully it doesn't move forward on me. No, it does. Okay, there we go. So yeah, I was talking with Paul and Carson, and just thought that it might be fun to talk about all of the stuff that we're learning with eBPF. I know it's been really interesting for us, and so hopefully there's some learnings that we can share, or maybe there's some things that we can learn from you all. So we're from QPoint, and QPoint we've been around for about 2 years now. And on this call, we've got myself, the CEO, Kevin, who is over sales. And then we also have Mark Barry, who is our CTO over engineering. And so we're just really excited about being able to dive into eBPF, and we'll talk about what we do towards the end. But like I said, yeah, super excited to be back at the Utah Kubernetes meetup. There's some interesting stuff here I'll talk about that connects the dots a little bit. But let's dive right in. So okay, I don't know. So I don't know how much everyone knows about eBPF. So we're just going to go through it. And I have an interesting origin story as it pertains to eBPF. And it's interesting. I mentioned up here Isovalent and Cilium because I was actually in this very meetup, the Utah Kubernetes meetup, back when it was in the Ancestry building. And there was a meetup, and then here comes this team. I'd never heard of them before, Cilium. And he gets up and he starts talking about his time at Red Hat and how he worked on the Linux kernel, and then he starts talking about this optimization that he found to kind of in-run the networking stack, and how some of the lessons that he learned from that he pulled from the BSD kernel could really optimize the networking path, and that they had kind of built at that time, there were, as many of you probably remember, there were a million different CNI options, and none of them were good. And Cilium kind of came around with a completely different take. And obviously the rest is history now. They just sold Isovalent. I'm not sure how to say their name, but it's the Cilium company just sold, and it was really cool to hear that story. But I remember, so at the time when I was sitting there in that meetup, and I don't know, how many of you remember that meetup, but I was sitting there and I was just blown away because so at that time I was I had started a company, and the cloud was still like trying to figure itself out, and I won't go too deep into this, but like just to kind of give you a sense, like this was probably like 2010 or so. I was building a product, and I really liked this idea of containers, and Solaris had this idea of zones. And so we were trying to like build this product on top of Linux, and I'm like, man, there's got to be some way that we can kind of bring some of this stuff over. And this was before containers. And there was this there's this one project on Linux that was actually owned by Red Hat, and it was I'm trying to remember what it was, but it was a container prior to container D. Anyway, I went and looked up the maintainers to kind of see if we could work on it. And I wrote an email to the maintainer who was working at Red Hat. I was like, hey, we do a lot with Solaris zones. We're currently writing a lot of Solaris kernel code, and wondering if we can kind of bring some of this stuff over to Linux, because it would be so much easier. There's just so much more portability, and applications run easier on Linux. And he just responded back, and he's like, sorry, short answer is there's no interest here. The concept of containers has fallen flat on the Linux community. And anyway, I just thought that was funny, because it wasn't too long after that that company Docker came around and changed that. But I say that, and it's important because what's fascinating about the origins of eBPF is it actually did not come from Linux. And so Solaris and BSD had this concept of the Berkeley Packet Filter, and Solaris had their version, which was pretty compatible, the Z-Trace, but they actually did more stuff, super cool stuff. And then the Cilium team that kind of came out of Red Hat kind of took those technologies and pulled them into the Linux kernel, primarily so that they could optimize the network path for Cilium. And boy, has it evolved since then, and it is really, really awesome to see that. So, anyway, it's a really fun journey that eBPF has been on. So, I don't know if some of you had similar experiences, kind of watching that, but anyway, okay. So moving on. All right. So at the end of the day, what is it? And to like really, really simplify it, there's a lot that's been said about eBPF, but it is literally a kernel module. There is no difference between a loaded eBPF app and a kernel module. In fact, so much so that if you want to run eBPF code, it has to be GPL compatibly licensed, because they consider it part of the kernel. And so you can kind of think of it as like it's a kernel module with safety that actually has a virtual machine. And I've heard that term a lot, the virtual machine. But really, like, what it boils down to is it's a verifier that verifies the code that you're about to put in, and then also some really, really strong restrictions about how long things run, what you have access to, what memory spaces can you or can you not. And so ultimately, you just want to make sure that you're not going to corrupt anything. And then you just attach to various event hooks in the kernel or probes. To date, while ultimately it is just it is just assembly, but that to my knowledge there are only 2 languages that have compilers that will compile the assembly that the verifier will accept, and that is C, which is the most widely accepted right now, the most support, and then also there is some support for Rust. It is not fully supported, and not everything is supported, but a really cool framework called IA if you wanted to check that out. But one of the questions that I get a lot is, does the whole app have to be in C or Rust? And absolutely not. In fact, if things go your way, much less of the code is actually written in C than the entirety of the app. So, Okay, cool. So how does this thing work? I don't know if this is visible. Is this visible okay? Can everyone actually see what this thing is? Probably tiny on the screen. If I need to zoom in, let me know. But it's really simple conceptually. You have eBPF apps, which are written in, I'm just going to say C from here on forward. I mean C and Rust if you're using IA and the IA compiler. But you write your eBPF apps in C, and they run within the Linux kernel space. And then your loader app can be any language that that supports the kind of the loading and serialization of the eBPF specification. And so for us, we use Golang. I'll get into that in just a minute. But the concept is essentially that, and it's called a loader app, regardless of what you call your app that's in the BPF land, they just call it the loader app. The loader app is basically whatever user space app loads the eBPF apps into the kernel. And when those apps get loaded into the kernel, the way that you communicate is through kind of two primitives, maps and buffers. And there's a lot of different types of maps. There's a couple different types of buffers, but the general concept is that with maps, you are setting data and getting data. It's a key value store, and that both the eBPF apps have access to, as well as your loader app. And so it's extremely powerful to be able to set data that the kernel apps can have access to and to retrieve that out. And then buffers are really one way. They're for your eBPF apps to publish data up through, and for your loader app to subscribe to that data as it comes out. So it's basically a pub sub. And so, like conceptually, it's simple. I know that in practice and implementation, it's not, but conceptually, it's very simple and it's extremely powerful. And I think one of the things that gets me so excited about eBPF, and now having used it as part of our core technology, the thing that's so exciting to me is that you can write an app that can literally communicate with the Linux kernel through your own API. And that app can do things within the kernel space that otherwise you would have to write a kernel module for, and you'd have to insert that kernel module, and you can blow up the kernel using modprobe. And so this is really great that with eBPF you cannot blow up the kernel, you can't crash the kernel. It's amazing. And then yeah, that it can grab stuff out and publish it up, and you can pull out all that data out. And this diagram that I created, I forgot to add, there's actually two other types of apps that you can write. So there's kprobes, uprobes, trace points. There's also XDP apps, and then there's TC apps, which we'll talk about. And again, feel free to stop me at any time. We can dive into this, but okay, so moving along here. So to get started in eBPF, you have a couple of choices of the frameworks to choose. And I'll make that first choice really simple for you. Do not use BCC, just don't do it. It doesn't matter if you've seen a project on GitHub that uses BCC, just don't do it. It's not portable, and you'll run into a lot of trouble across architecture, lots and lots of compiling. And you essentially have to compile a version of your app for every single different kernel that exists, which is no good. libbpf, so much better. It uses a concept called co-re, which is compile once, read everywhere. And so you compile it once, run. Compile once, run anywhere. And it will run on any Linux kernel. It is amazing. It's so much better. IA is the hot new framework that uses Rust. It is pretty tempting, but that said, Cilium is rock solid. And when I say rock solid, I mean rock solid. They have support for everything. Everything works. It is great, and it uses Go. And then, yeah, with BPF to Go, I mean, it's incredible. It literally, we'll show you here, but Okay, yeah, and then we back to the primitives. We've got maps, which is key value store, your buffers, there's your pub sub. Kprobe, which allows you to attach to kernel functions. And what's really cool about that is not only are you attaching to these kernel functions, so you can attach to the entry of that function, you can attach to the return of that function, you have direct access to the memory in kernel for both of those. You can also modify that memory, and you have to do it safely and you have to do it within the rules, but you can modify those values. It's extremely powerful. Same thing with uprobe, user space functions. We are using it to tap into SSL read and write functions for various SSL libraries, and it's really powerful. And then you have trace points, which are read-only events that the kernel emits. So this can be a syscall. Anytime a syscall is made, you can get an event for it or probed into it. And then lots of other stuff that they make available for monitoring, observability, that sort of thing. And then lastly, what was built for was the XDP-TC stuff, which is the express data path and the traffic control apps, which literally are meant for bypassing the networking stack and optimizing just incredible stuff there. So very, very modern load balancers, routers. That's how Cilium works, and part of the thing we're going to run through today. So, okay, any questions on this before we kind of, now that we got all that out of the way, we can kind of move on to the fun stuff. So just generally, any questions about eBPF concepts, libraries, frameworks, whatever, before we move to the next?
Tyler, maybe just a quick question. I mean, typically, when it was first started, it was packet filtering. I mean, it was traffic, network traffic. It was doing pretty much that world. When did it kind of go a little bit broader, and where have you seen it actually? How wide have you seen it go?
Yeah. So to answer that first question, it happened when it wasn't just Cilium. So Cilium is, they're the eBPF company that pushed this ecosystem forward. Very much they were the impetus, but there is a lot of other work that happened from Intel, from other chip makers to kind of run certain things on NIC to optimize to offload a lot of the packet processing onto NICs directly, and a lot of stuff happened at scale that it kind of was behind the scenes. But what ended up happening was that it started as this kind of like express data path traffic control type of applications. But the challenge was actually, how do you introduce this logic into the Linux kernel safely? And what it has become today was not initially foreseen. And so there was a lot of buy-in from the kernel developers and the core Linux team, because they were trying to just like make this work. They could see the optimizations, they could see the scale challenges. There was a lot of work at that time trying to figure out how to get bonded NICs to work at extremely high throughput, and so there was a lot of collaboration trying to get these things going. And then what they realized is after they had built so much of this verifier and the safe code running in the kernel, they realized they had kind of created a virtual machine, and why limit it to just the networking stack? And so that started to expand. What if we let this run anywhere? What if we let this run everywhere? What if we literally allow someone to attach to every single kernel function that exists in the Linux kernel? And it's like, well, what's the worst that could happen? And they started to realize the verifier was so strict that you just couldn't crash the kernel. So okay, and so from that point, it just kind of became this virtual machine. I know that Brendan Gregg, if any of you are familiar with him, Brendan Gregg likes to call it JavaScript in the Linux kernel. And I think that is a very, very accurate analogy. and a very incorrect concept if you're familiar with JavaScript and how easy that is, and then trying to get C code to work in the kernel. It's very different, but conceptually, yeah. So that's kind of where that happened. It was kind of one of those like, let's get this in for one use case, and then we had built so much tooling around it, and they had realized that it was so good that they started to expand it, and they're still expanding different trace points and different events, and so yeah, it's pretty incredible, pretty powerful at this point. Yeah. At this point, it's actually accessible, and I think that's really the milestone. Like anybody can really pick it up, and anybody who has the patience to kind of work through some of these things, and lots of businesses are being picked up on it, and Kevin and I talk, and we're always on the investment circuit, and yeah, eBPF is a really big hot topic for institutionalized capital at this point. Yeah. So, yeah, great question. Any others before we move on here? Cool. So let's look at our real use case. This is our use case, and we're not going to dwell on this. I just wanted to go from like, okay, conceptual, that's cool, but like, what can you really do with this thing? And here's an example here where, so in this diagram, we've got a Linux host that's split into two parts. We've got our user space apps, the PHPs, the Rubies, the Golangs, the Node.js's, and then you've got your Linux kernel. And all of those apps at some point or another are going to try to talk to the outside world. And that's kind of the gap that QPoint is looking to solve. And so what we ended up doing is we realized that we can that we can create two different types of eBPF apps. One of them is, socket probes and TLS probes, and what that does is essentially it taps into the socket layer of the kernel for plain text traffic, and then also for TLS probes we can tap into the SSL read and write functions for the various SSL encryption libraries that exist out there. And so we can essentially take a read-only copy of that data as it flows through the system, unobstructed. We can take a copy of that data and we can push it up into what we call QTAP. And then that there within the app that allows us to do things like detect the endpoint, extract any metadata, detect errors, scan PII, etc. And then we can go and report that off through OTel or through our own control plane. And anyway, and so it is extremely powerful. There's so many applications, and in our case, it was it's worked really well. And I'll show you down here in the end, but. Super cool stuff. So next question is like, so what does this stuff even look like? And I'm gonna share my whole screen here in a bit, and we're actually gonna look. We're gonna look through a real use case. This use case actually came from Netflix, so we'll look at the use case. But before we do that, like, what does it look like? So first thing we look at is actually the C code itself. So the probes. And
we'll keep that use case under friend DA with the group, just as a reminder.
Yeah. Friend DA. Yeah.
Wait, isn't the C code have to be GPL licensed?
It's true. This stuff here is the stuff that I'm going to show you here is very likely to be. Well, this is going to be open source. The C code is already.
Yeah,
but
actually, right.
We'll show, yeah, it does, and we'll show you some of the Go code that's not really like pertinent. That's kind of more like anyway. But yeah, let's look at these probes here. So the first thing, it might kind of look really weird, but we kind of have it structured here where we've got at the very top we have what looks like a struct, and it is sort of a struct, but it's packed especially, and that actually gives us a ring buffer, and that buffer allows us to push data through that ring buffer and have our user app pull data out. And So those events can be of any type. It does not matter what type it is through this ring buffer, as long as both sides understand as long as you're pushing binary data through it, and as long as the other side understands kind of what's coming out of it, then it doesn't matter. So there's no typing necessary on the ring buffer. But then we go down, we have a helper function here, which is just a C helper function. And then down below, we have 2 different trace points. And these are tracing into syscalls. So this syscall right here, one of them is the exec CV, which is when a new process execs. Mm-hmm. And then the other one is just a variation of that, exec CVEAT. So these are just 2 different syscalls. And so when those get fired, we then call our helper function that essentially creates an event, an info event here, and sets the type to a process exec type. And that's just a type that we defined. And then sets the PID, it uses a helper in libbpf to get the current PID, and then it basically shifts off 32 bits so that all you're left with is the PID of the process, not the thread group. And then we just push it through that buffer. So at this point, we have these events pushing up data into the app. Okay, so then we go and look at the make file. It's really not bad. I included the BPF to go part, and the main reason. So the top part of the BPF _ source all the way down to clean is really all that it takes. It just anything that's anything in that directory that's that's a .c file will get compiled up into a single binary, and then we use this tool from Cilium called BPF to go, and it will make your life so much easier. It literally takes all of that code and it packages it up. It packages it up into the Golang binary, and then it also creates all of the corresponding Go types so that you can talk to the other side of the pipe. Pretty incredible. Okay, so the make file, not a big deal. So then what are we looking at here? So if we've got types on the C side on the left, we just have to write the corresponding event types on the right, and BPF to go will generate these for you. But we kind of take those as a starting point, and then we modify them because we do extra stuff in Go we don't do in C, and so anyway, we just make sure that they're aligned on the typing. Sometimes you have to add some padding, that sort of thing. But okay, so now that we've got our structs aligned, then from in the Golang app, we have to attach the probes and open a buffer reader. So all of this stuff here, I didn't include the prelude because it's all this stuff is right off of, this is all open source stuff from Cilium. You just create these trace points of like what area of the system, what event, and then this OBJS thing is what BPF to go creates. So you can actually say this app that is compiled, it's actually compiled and served up in a Go binary. Attach that program, and then you go down and just you then open up a ring buffer reader, and with that ring buffer reader, we can in a for loop just continue to read into ring buffer records. And as we get those records out of that, as fast as they're coming out of the kernel, then we just say, okay, well, let's read that. Let's read the proc event, and we just kind of go through and, well, what's the event type, exec, exit, mmap, rename, etc. And then we pull that into its own handler, which basically just does a binary read into a specific type, so exec event, and then boom, we have a Go pointer that matches a certain type, and we can do whatever we want to do with it. So pretty simple stuff like that. So all this is that we're showing here is just like the Cilium stuff. Like that's the Sorry, what was that?
What I practiced.
Okay.
I just picked up some low level murmur. It's
Okay, cool.
our most junior member.
Nice. Any questions about that? Any of this stuff, kind of how it works?
Sense.
Cool. Okay, so now let's get to kind of a real scenario here, and we've got a new challenge. Okay, so we have a challenge, and this is probably not unlike any of the challenges that you may face as platform teams, and that is that you want to have some control over the data that's leaving your network. You want to actually, maybe you want to crack into it. You want to inspect the data, modify the data, and then forward it along. Well, we were talking. We've talked with so many teams at large scale teams, and one of them we talked to was one of the teams at Facebook. And I'm only saying this because it's not unique to Facebook. This is not a Facebook problem. This is just you might even have seen the same scenario. They've got a challenge, and the team we talked to is on the platform team. They have a mandate that they need to ensure that certain things, that certain data is processed a certain way, that certain things happen on the way out, and the problem is that with a team like Netflix, you literally have thousands of employees and hundreds of teams. And so the problem with egress is you're like, well, okay, we need to have control over this traffic, but you need to do two things. One, you need to implement a proxy, like in between all of the stuff that you're sending out and the stuff you're sending out. And we need a man in the middle of that thing. And so we actually need you to put a certificate authority, a custom certificate authority in there. And then the security team comes and says, no, you will not do that, because if we have a man in the middle anywhere on our network and a certificate authority, and that certificate authority gets out, then somebody can compromise that network device and have access to all of network traffic leaving. So we cannot have an SSL cert that at the network level. We kind of have to have individual one-off SSL certificate authority certs on each node that is short-lived and that cycles out. And they're like, how are we going to do, like, we can't even get these teams to do things the right way and all these other aspects. How the heck are we going to get them to do that, to implement these things? And they're just like, so of course it gets punted. Well, so we started talking to them, and I'm only just using them as an example. Lots of other teams are in this kind of similar boat. And we started to think about this, and we're like, okay, actually, here's something interesting. What if we use eBPF and traffic control to redirect the request on as it's coming out, and we hoist that connection up into a user space app where we can terminate the SSL, and then we can do whatever you need to right there on the node. It doesn't have to leave, doesn't have to go across the network, right there. Then it will re-encrypt. I put that in the wrong order. Re-encrypt, then forward. Drops it right back on the network, and then it goes out, and everybody's happy. Security's happy. The platform teams are happy. The developers are happy because they don't have to do anything literally at all. So it's like, okay, great. So how are we going to do this? And so as we looked at it, we're like, okay, there's two parts of this problem. Part one is in creating kind of a transparent egress controller is we have to do the transparent redirect. Okay, well, for that, we use TC, which is traffic control. That's an eBPF app that we can use. And eBPF was built for this very purpose. So aside from some very just tricky business logic and routing logic and making sure that maps line up and that you've got data and unmarking and whatever, like aside from that, like that problem is mostly a solved problem in the eBPF world. The next problem that we run into is how are we going to, in order to do the SSL termination, we do have to use a certificate authority. Even though it's on the same node, we still have to use a certificate authority, or else this client is going to freak out. And so the question is, how do we do that? Well, this is a really old problem. Every team's had to encounter this at some point. If they ever want to do any sort of decryption, you use certificate authorities. But it's really hard for distributed teams, and it's really insecure for distributed teams. And so it's time for a brand new approach. And so we kind of came up with this approach, which is let's use eBPF literally to intercept the file system calls to a certificate authority, and let's append the custom cert onto the end of it. And so we whip up a prototype and like, okay, that's awesome. We can do that. Oops, a little too far. It scared people. They're like, we don't like you injecting that into our kernel. We don't like that you're tapping into the file system for for all reads. There's got to be kind of somewhere in the middle. Okay, so what we came up with was we need an approach where we can take a certificate authority that they can provide a certificate authority, and we can kind of inject that into the files as they exist, on the system, but in a way that's totally transparent and in a way that doesn't do too much. And so what we ended up landing on, and I ended up running out of time to kind of draw this up. So we'll just actually go in and look at the code here. But here's essentially the process that we landed on that kind of has that happy medium, which is number one. So we in our loader app, we attach events to like processes coming online. And when a process comes online, we literally get that event before the process is even online, because the moment that syscall boundary is crossed, we get the event. We already have an app loaded, and we can immediately see, okay, here's an app that's coming online. Does it belong to a container? If it does belong to a container, let's go and look at that container. Let's go see if there are any certificate authorities that are on that machine, and if there are, then let's copy those certificate authorities into a temporary file, append the custom injected certificate to the end, and then bind mount on top, so that the whole process is transparent. But we use eBPF to do that in real time, without any delay, any lag. And then by the time that the app comes online, that's already been done. And we can add one extra layer of security, which is we can get a notification. So we're not going to trace all your file system reads, but we can get a notification whenever a certificate authority file was read, just that it was read. And we can bubble that up, and we can say, okay, this process read, and it actually read it after it was mounted. We're safe to go ahead and apply the transparent redirect, and it'll be happy. So security's happy because now we can dynamically create a certificate authority on the node. No network traffic leaves the node at all. And if they take that custom cert and try to use it anywhere else, it's not going to work. And then it's fully transparent, and we satisfy the requirements. So okay, I'm just looking. I know we're running a little bit late here, so I'll run through this real quick before I share my screen. Any questions on kind of what we're going to do here? Okay. So let's go and change. Let's go to the entire screen and let me know if this doesn't, let's see, infinity mirror. Okay, got it. And hide. Okay. Let's see if I can find the right window here.
We're looking at half of your Slack screen, but not the.
How about this one?
Google Meet's been pretty bad lately on Macs for whatever reason. When you change virtual desktops, it stops sharing. It's usually better if you can share a specific window.
Okay, let me try this then. Let's try to present a window. Shoot. Well, what I may have to do, I've got windows on a different, let me try this one more time. And if it doesn't work, then I'll have to.
Desktop, is that the issue?
Yeah, yeah. I have a little bit of ADD, so I have to have every, like, I can't have any clutter.
It should.
All right, let's try this. Are you able to see my editor?
Frozen. If you're moving your cursor, we're not seeing it, unfortunately.
Okay.
I'm putting
Well,
on the same virtual desktop as your.
yeah, let me do this. Let me just move that to that desktop.
Move your browser over.
Yeah. Okay. So let's go. Let's pull this out. Go over here.
This version of Mac changed how you share screen and requires all apps. Forms that.
Is that really what happened?
Ask me how I know.
That explains a lot because it's been a source of consternation.
Yes.
Okay.
I'm trying to be nice. We're still on record.
Let me try this. So let's jump to the implementation here. Let's see. Okay. I'm sharing a window. This is my terminal. Let's first start here, then we'll kind of move over to the editor. So we're on a terminal, and okay, so what I'm going to do is I have, this is a Debian system, and I'm just going to run the QPoint inject CA, and I'm going to provide it the temp certificate.crt. And when we run this, so we'll see it running, then we'll go see how, like, we put that together. So we run it, and it comes online, and we say, okay, we've got the injector loaded, probes attached, and guess what? We found a cert file. It is in etc SSL certs CA certificate. Okay, so let's just go in another tab, open up here. Let's just go and cat that file. And we notice at the bottom of this file is a custom injected certificate. Cool. Well, let's go and stop this program and then come and do that again. It's gone. So when we run the program, and then we'll actually see, again, we found it. Let's run another container on a container on that that node. So let's go like Docker run Alpine. And we find again, hey, we found another cert file. Cool. But this time it's in a container. All right. So we go and check out this cert file. And let's actually just cat that file. There we go. There it is again inside that container. And if we stop the program, but the container is still running, it's gone. So accomplished. We're able to kind of accomplish that goal. So now let's kind of look at how that works. And let me see if I can do this. I might have to, so now I got to like stop sharing. and move my thing to the next window. Okay. And I'm just going to run through this briefly because I'm under the assumption that this stuff is way more exciting to me than anybody probably cares about.
Well,
So,
you're kind of a master of doing really amazing things and then like underselling them, right? Like, because you kind of breeze past the point where you're like, the first we did this thing to solve the problem where when you would cat a file, we would give you that file and some totally different contents. Like the reason I really like, yeah, that's cool. Like that's a really simple illustration of, I think, eBPF that I had never thought of until you told me you were doing it. Of, yeah, you can make the kernel just do whatever you want when you load an eBPF module. Like the idea that you would get a file, someone would ask you for the contents of a file, and you could just give them something else.
Yep.
All
yeah,
your
exactly.
fundamental assumptions break. Even this idea of like attaching to processes and like manipulating a process's view of the world when it boots up before it even starts is cool. I mean, I think it's cool. I don't know.
It is. We're super stoked about it, and obviously, I'm not. There's parts of this source code I can't put on camera here, but there's pieces of it that we know over time we'd love to turn into libraries to help other people build stuff that's unrelated to the problem space we're in. And I'll show you one of those. So the core of a lot of what we do is we watch for files for process events. So that was kind of the stuff that I was showing you there, where. So we have a manager that essentially will that allows you to register observers in other parts of the system, and we then are reading these events as they come through this pipeline, this pub/sub pipeline. And so as an example, we get a new exec event. Hey, a process was added. So what we can actually do is we can say, okay, we've got a new process. Here's its PID. And then we've got a whole process that will go and extract all the information about that process to give us all of this information here. And now that we have all that information, what we can do is we can actually go back and look at the simplicity. Now that we have an observability pipeline, we can actually come into this CA. Let's say we can create a manager for our certificate authority, and it's observing processes as they come online. So whenever a process comes online and the kernel's just telling us that a process is coming online, we can say, hey, is there a container attached? If there is a container, then let's create a new container struct. And we know where all of the cert files are for all these different distributions. So when that comes online, let's just check and see if this particular container has any of those. And if it does have any of those, then we go through the process of the mount process of doing whatever we need to copy and then do a bind mount and all that, and it's all transparent to the system. You can look at the mount tab and everything, but essentially using eBPF, we're able to. And I'll show you this. This is the open source. Like this right here is fully open source. This is all of our BPF code. And so what that ends up looking like, this one's our one of the simplest ones. That's why I show it. We define all of our events, the proc events, and then we just respond to these events, bubble them up, and then we have all sorts of Go processes that respond accordingly. And then for our more complex ones, which there are, quite a bit of complex ones for tapping into different parts of the system, we're able to do some other really, really cool stuff. So yeah, eBPF is actually pretty amazing, honestly. Like it's super amazing. Let me just back over here for a sec. And I'm really struggling with the different windows here. So what I'd like to do is, I know we're already kind of at an hour and don't want to go too much, past that, but let me try to do one last thing here. Okay, so let me share this again. Tab. Let me get back up here. So we were able to use this to create a business. We were able to use eBPF to solve a real problem that exists. And Carson's very familiar with this problem. In fact, when we started this business, we were solving a different problem. And Carson was part of a panel that we put together that was like, no, actually the gap that exists is that modern applications are highly connected, and and all these modern apps have critical external dependencies. The apps talk to the outside world, and operators are really struggling with visibility, with uptime, with understanding what leaves our network. When we have an outage, are we aware of it? Do we know if we're using API tokens that have expired? All sorts of issues. And so we were actually able to create a solution around that problem that uses eBPF to expose all of this data out of the kernel. And let me just ask, are we up on time here, Paul, or do I have 5 minutes to do a real quick?
Take whatever you need, Tyler. Please take your time.
Okay, let me try again. Now I've got to go back. What I'm going to do, let me try to move this whole window here. Go back here, and then I'm going to move my window over to where my terminal is. Okay, let's see if we can do this. So to start, I'm going to start with our dashboard, which is where the experience starts. Okay, so we're going to create an organization here, and with our control plane. And yeah, this part's boring. This just basically goes and sets up all of the necessary account stuff and plumbing and blah blah blah. Okay, so now we've dropped into our control plane here, and we can go and install a QTAP. Now we were proxy based, and the proxy still works, but we have now moved over our technology over to eBPF for a whole bunch of reasons, as you already saw some of them. So let's go ahead and install, and we've got a couple different choices here. I'm going to choose Docker because that's just nice and simple, even though Kubernetes is simple too. Actually, I'll just show you with Kubernetes. If you use Helm, that's 2 steps done, and then it's up and running. It's a daemon set, and it'll run on each of your nodes. And then, of course, you can pin it if you want to roll it out slowly. But for this presentation, I'm just going to run this inside of a container. Okay, since I can only share one, the screen sharing thing is a little bit weird here. What I'm going to do is I'm going to actually copy this command and run it in the terminal without switching over. And you'll see it, it starts up and runs, and then we'll see as soon as it fires up, it connects into the control plane, and then it once it registers, there we go. Looks like we are online. Okay, and this is just our default installation. Okay, so eventful there. Okay, so I don't have anything running in it, and admittedly, this demo is not nearly as impressive when I have to kind of do the screen sharing thing. But I'll just explain. In my terminal right now, I'm going to start an app. So this app is basically just going to it's going to do a couple of things. The first thing, it's going to actually build a Docker image. So I'm typing I'm running a Docker file, and it's going to build the Docker image, and then it's going to run the app. The reason I do that is because all of the interaction that happens as we start to build that image, as we start to talk to various Docker registries, Docker Hub, and others start to show up. All of the traffic that is leaving our network starts to show up. We start to see it. And then once that app comes online, which it's doing an npm install, and I'm sure you all know how that goes. So.
Insert NPM joke here.
Yes. Exactly. Yeah.
Could you have solved left bad?
What's that? Sorry.
Could you have solved left bad with eBPF?
Yeah. Mm-hmm.
You can do everything.
Yeah, it's really freaking cool, honestly. You can solve anything if you have the patience to figure out how to do it in the kernel space. It's like I'm not going to sugarcoat it. It's hard, and like the reason it's hard is not because it's C, is because it's a restricted version of C. There we go. Now the app's coming online. It's talking to the outside world. It's making calls, and we're actually now getting in the middle of those, and we'll see here. We'll start to see some of these requests fail. We're getting durations, we're getting availability, all sorts of insights here. And what this allows us to do, and I'll show you. This is a little bit of there we go. Boom. So a little bit of our flair here. So on top of the eBPF is we're really big fans of middleware pattern. And so essentially what we have built is a way to kind of take this read-only copy of the data and then run it through a pipeline of middleware. And so we've got our standard library. One of them is detect errors here, which you'll see, which allows us to look for all sorts of different types of errors. We do have quite a bit of others that you can add in here. But basically that's what's giving us all of this. And so now that we have all of this, we can actually come in and say, okay, what the heck's going on with AWS? We can actually see our AWS endpoint, and already, like, as operators, it's just like, finally I can see this thing, and it is not looking good. We've got some really nasty uptime. We've got a lot of errors. We have a bunch of connections that we can see, and they're all failing, but we have a lot of information here that we can gather. We can see the clients where this stuff is coming from. We can actually see the errors, like, what is it? Oh, it's a client error. Well, what is the client error? We can look in. We've got a bunch of different, we've got examples of kind of where it went. We can pop open one of these things, and we can see if there was any auth data. And if I had configured an S3 bucket for storing payloads that match certain criteria, failure criteria, then those payloads would show up here.
So,
Go ahead.
I think there's something. The really cool part of this is almost going unsaid. So I don't want to get in your way, but like the fact that you have all of that data for all of those APIs, all of which are encrypted, and that's all done without change to anything about your app. It's just that eBPF program, right? Like, you run the tap, and it's sitting there messing with both intercepting connections and messing with how the cert files get bound, not get read anymore, but how you're changing that. Like, that's pretty cool. That's, I'm huge on the products. I don't want to like interrupt your awesome product spiel, but like, it's sort of for the broader view of the group and the cloud native space, like that's not, you obviously have, there's devil in the details, but not like a whole new concept of ideas to be able to be like, and I built a product that just transparently attaches and can kind of sit in front of your even encrypted connections and securely help us get some of this data that we need to give you visibility in a way that you just couldn't get with any other tool. So I don't know, I think it's cool. It's cool that this is even getting HTTPS data without you doing nothing to the program.
Yeah, that's the idea.
Yeah,
You said
and
it,
I haven't
you-
seen it anyway. That's why I keep talking about you, because it's never seen
Awesome.
anyone else do it that
That's cool.
swiftly.
And well, thanks for that. And I'll wrap up here. But essentially, what this gives us is we have a log of every single interaction that takes place outside of your network. You can pull it up, and you can actually see where it came from. You can see the socket type, the executable, the container it came from, the user, the system user, the source port. It pretty much, everything you need to know about that, and you can hold your vendors accountable when things fail, when things are not working properly. And I'm going to just switch from a demo and show you a real quick thing here. Let's go. And okay, so if this thing were, not a demo and we're actually fully loaded, you start to get some really interesting inventory here, where you have a list of all of the vendors. We can show you all of the vendors that you're using, the availability, the various endpoints, the clients, any errors, API tokens that are being used. We can break that down by clients, whether that's the executable or pod or whatever, and we can do that same thing. Look at all this information. Same thing with the specific endpoints. We're working on this aspect here, but we don't have this in the UI yet, but we're able to kind of understand the sensitive data, where it's coming from, where specifically all that's coming from. And then also one that Carson's worked with us on is, as a design partner, is really surfacing the API tokens, which API tokens are being used. And of course, we don't store that token. We just have a mask token with a hash, but we at least can show you all of the tokens that are being used. And the amount of bandwidth that is responsible, that token is responsible, the last time it was used, all that sort of stuff. So, and then alerts and all that stuff. So I'll go ahead and stop sharing now, but we're super excited, honestly, because back to kind of the beginning of this, as I was sitting in this very meetup listening to Cilium before Cilium was anything, it was like so captivating. And I remember at that time thinking, and I was actually had a cloud company at the time that was doing some pretty deep stuff with. And I just remember thinking, like, man, this is cool. I would love to be able to build an eBPF company at some point. And that wasn't the plan, but 6 years later, and we've got this product, and nobody wants to implement a proxy, and nobody wants to do a man in the middle. And operators like, no, gross. We don't want to change the design of our infrastructure. We don't want to, we're not doing that. And so it's like, oh, eBPF. Yeah, we can use eBPF, and it's totally worked out for us. And so we're super stoked on it, and we're really bullish on the tech. So. That's it. Any questions? I'd love to answer any questions you may have about anything about eBPF, about our technology, our product, anything. Yeah.
Any questions for? All right. Well, thank you very much.
Awesome. Thank you.